This video is part of the Commercial Building Electrical Design series. We're still talking about lighting design and lighting sources. And this video we're looking at metal halide type light sources. Again, taking stock of where we are in the videos, still talking about lighting design. We've gone through terms and definitions. We're going through lighting sources. So this is the second of the HID type lighting that we want to look at, which is metal halide. Again, HID lighting is widely used exterior source for a lot of commercial applications. We would now want to look at the metal halide types of these lights, which is considered a close cousin to the mercury vapor type, which we just talked about in the previous video. So this lamp also uses mercury along with metal halides, which in most cases is bromine or iodine, to form the arcing gas, which improves the efficiency and color rendition of the light. So as far as the efficacy, this is better than mercury vapor, and it's usually considered pretty good. We usually see these fall in the range of anywhere from 75 to 100 lumens per watt. So while these fixtures do outperform mercury vapor in many other categories, lamp life is not necessarily one of them, although it is comparable. As before we saw the mercury vapor, we would expect 20 to 25. We usually limit the metal halide to 20,000 hours max. So metal halide fixtures will typically experience some depreciation that contribute to the light loss factor. So for typical use for these type of fixtures, we usually see the light loss factor in the range of 80%, which is better than the 50 to 60% for the mercury vapor. So it is better in that regards. The spectral power distribution for metal halide lamps is typically considered to be the best out of all the HID sources. These types of fixtures generally provide good spectrum coverage for most part of the color spectrum. The performance is very good for most exterior commercial applications and uses. Again, though, as before, we need to keep in mind that it does utilize UV light in the process of creating light, so there most certainly will almost always be some amount of leakage, so you need to be careful if you're using this with textiles or art. So here in this graph, you can see we do have pretty good coverage across the board for this type of fixture. As we've seen before, and with most fixtures, the coefficient of utilization depends on a lot of different things, but for the things that depend on the source, this metal halide is usually considered a pretty good fixture in this regard. Other issues of interest related to different sources, as we've seen before, control, warm up, and restart. So due to the need to strike an arc, just like with the mercury vapor, these type of fixtures sometimes don't do well in cold weather, and they can sometimes require 10 to 15 minutes to warm up from cold or hot starts going from blue to white light. So it's one thing that is a little bit challenging with these types of lights, like if you use them in a gymnasium. If they were to lose power, you can't just flip the lights right back on and go back to playing the basketball game, because it takes them a while to warm up. So these types of fixtures do have the capability to be dimmed with a dimming ballast, and they are many times utilized in combination gymnasium auditorium applications. Metal halide lighting is generally considered a good option for most exterior commercial applications where color rendering is important. It is typically one of the more expensive installation cost options. That being said, there are some constraints that the designer needs to be aware of, such as the restart issues. So these types of fixtures also have many interior lighting applications as well as exterior applications, and so you can see them in both applications.